heard about real-time? Did anyone tried real-time? You don't have. Okay, cool. So first of all, thank you for inviting me. The goal is to share a little bit with you what we have learned in this process of scaling, basically a cloud service, messaging cloud service. There are other services, but the main one is a messaging cloud service. And I have the pleasure of leading the team that develops and operates this platform. So back in 2010, we were asking ourselves, why does the web still works as a walkie-talkie? Why do we have to request and then wait for the response? And why can't we do it in a bidirectional way with browsers, just like we do with other applications, with other server applications in Java or whatever? And we had this customer. So we were running, previously the company was developing basically e-commerce solutions. And we had this customer that wanted to update the product stock. Like you would have a very small amount of items, stocking units. You would put them for sale at 10 o'clock. And he would like to, as soon as he is selling each item, the users in his website would see the stock decreasing, and they would rush to buy it. So something like we have just by the way, we are using the most expensive HDMI cable in the world, which is a Mac. So I'm Skyping to a Mac, and the Mac is connected to the screen because my laptop doesn't have HDMI and the screen doesn't have VGA. So first problem world. So if Skype falls, sounds like a Bond movie. So you have the stock there, and basically you just want to update it without the user making the refresh. There are two options. One is to do the refresh in the website, which probably refreshing the old page would not be good. The other option would be, okay, let's poll the server each second. And let's hope we don't have a lot of users. Otherwise, our server would stress out with all these requests, and probably most of them would just have the same amount of information, saying the same amount of stock. So it would be a waste of bandwidth. And keep in mind that each request would be an HTTP request, and with all the errors that HTTP has and stuff like that. So gratefully, the industry came together and created the WebSocket protocol, which we have already seen today. So this really shows the moment where we are today. So back in 2011, when we showed real time, we were talking about WebSocket, and some guys were looking into it for the first time now. A very a very cool example with streams is using WebSockets out of the box. So cool, a new standard, basically a two-way communication between the server and the browser, which would be great. And we would say, okay, now we have two-way communication between servers and browsers, but what about the scalability of this thing? What about massive broadcasts? Because a WebSocket is a socket between a server and a client. So if I want to broadcast my socket to 10,000 WebSockets, I have to do something on my side to do that. WebSocket alone doesn't solve me this problem. What about the security? If I want to control who can establish a WebSocket with my server. What about legacy browsers? If someone is still using IE8 or IE6, by no chance the WebSocket would work. And obviously the costs in all this, not only the infrastructure costs, but the development costs involved in all the R&D and all the development. So we basically in 2010 we were thinking it would be cool to have this as a service, to offer developers. Place a platform where you would subscribe, and you would get an application key, some sort of authentication, and you would just start using our own infrastructure, and we would take care of the scalability for you. So you have this cloud service. We would implement pub/sub pattern where some browser could subscribe to channel update, and we would have a callback F that would receive a message. The message could contain some payload, in this case the stock. So you could have several different devices subscribing. You could have a publisher, in this case probably the web server, the application server that knows in the transaction that is decreasing the stock. You could just publish a message. And you publish this JSON object saying the stock is 10. You send it to the real-time platform, and we would broadcast it, deliver it to all the other subscribers. And it would be obviously great if we could do this for all the browsers, including old browsers like IE6, all the mobile platforms from iOS, Android, and Windows Phone, and also for other platforms. In fact, we have all this that you see here. Today we launched for Xamarin, the support for Xamarin. We also have for React Mobile, which is great. If you haven't yet taken a look at it, it's great, the new thing from Facebook. So when a talk without a demo is not a talk. So could you please open in your whoever has a device, connected device, that URL framework.realtime.co/demo/stock. I will.
For those of you who don't have that data access, the SSID for the Wi-Fi is over there, and the password is beer and Wi-Fi.
Which is a great /demo/stock. Okay.
Yeah, but don't use the Wi-Fi or Skype will disregard that.
Okay, cool. So basically we have a browser here under the hood, and I'll show you it in a while. There is a WebSocket connected to, you see there connected. And here in my phone I have a different page, which in fact is /admin.html, which simulates the application server, and I will start sending stock updates. So if you look into that value there, the 20, I will start sending messages, and it will be updating there, and hopefully updating in your own devices too. Okay. So there's no black magic here, as you probably know. So if I refresh it again, so it goes back to 20 because this is just an HTML page. You can run it in file column // So you can see there you have this WebSocket connected to real-time code, and Chrome has this nice feature that allows you to inspect the frames. And as I'm sending messages here, you probably, I don't know if you can see, but you see all these little frames going on there. So in terms of the code you need to do this, I don't want to spend a lot of time here, I want to go further. Just looking here at the product update. So basically you establish a connection with your own API key, which you get from subscribing. You connect to a certain URL that we give you, and when it's connected, we write the little connected that you've seen underneath, and you subscribe to stock update channel, and whenever there is a message in the stock update, we call this function, and this function basically updates and blinks the value. So you have an event emitter that it's global, and it's you are emitting events. I was emitting events in my iOS phone, was sending it to the real-time platform, and was relaying, broadcasting these events, this JSON event, these JSON payloads to all the subscribers. It's as simple as that. Obviously, then you get authentication, you get security, it can get a bit more complex, but it's pretty much this that real-time messaging offers you. And obviously, we will charge you something for the messages you send above a certain level. We have a considerably large free tier that you can use for free. But that's not the point of. I don't want to make this into a vendor briefing or a sales pitch, so just check it out. If you want to run these examples yourself, you have in GitHub, in my GitHub stock, and you have the iOS, native iOS app that basically receives also the updates. So at the moment we have, I always like the precision of this number, which is always wrong. Every time I show this slide, I keep updating it. So we have about 5,000 developers around the world. Mostly they are in Europe, in Brazil, and the US. Over 5,000 applications that are in the wild using it. I don't know if you know Township. Township is a game just like SimCity or Farmville, more Farmville. And well, you would be amazed. They have normally always 150K concurrent users playing the game 24 hours during the day. Not the same users. We see them coming from different parts of the globe as the apparent travel of the sun is going on. And also we have the Golden Manager, the game from Piqué from Barcelona. It's also using real time to synchronize the game. And we have a lot of second screen apps. You're familiar with the concept? Those apps that are connected to a TV show that the user can interact. Last week, TVI launched the Você na TV app using real time. So Gosha is using real time. That's pretty much sums up the democracy of real time. So last but not the least, we have our largest customer is Web Spectator. Web Spectator is an American company that was a spin-off from Real Time. They are an advertising platform that is doing something different. They are monetizing user time and attention. Not the number of times your banner shows in the page, but the time it's viewable inside the page. And they anticipated all this viewability thing that's going on now with all the great brands that I don't know if you probably know that if you are an advertiser today, if your banner is below the fold, so if it never shows up in the page but it was printed because you never scrolled, you pay for that. Now the new rules say that you must have it must be 50% in the screen, the viewport, for 1 second. Nonsense. In fact, Web Spectator has a different offer. They credited the GTS, the guaranteed time slot, which gives you 20 seconds. So you pay for 20 seconds of viewport time inside the browser of the user. And they also give their customers this wonderful dashboard where, in fact, brands can see how many users are not only seeing their banners, but interacting with the page where the banners are. If they are scrolling, if they are moving the mouse. So it's great. And obviously they are integrated with Google, and you can have both of two ones. And they, in these 3 years of activity, business activity, they have reached 450 million users. So they are pretty much three quarters of our size. So most users come from Web Spectator. And why? How can they reach this level of? So this is monthly active users. So every month, 500 million, 450 million different persons interact, because they have companies like Forbes, TMZ, all the publications from Condé Nast and Budweiser and others. They are including their JavaScript in their own pages. So page view in Forms is a connect to real-time platform. And I'll just show you that, which is kind of cool. If we go to the F12, let's go into Forbes. Let's switch to network. And at some point, depending on the campaigns that are going on, you see there is this WebSocket connected to real-time code. And this is happening for every page in Forbes and in TMZ. I don't know if you know the website TMZ. So TMZ is the gossip website of Hollywood. And yesterday or 2 days ago, we had this huge spike because Bruce Jenner now is called Caitlyn Jenner. So now he's a woman. And TMZ published his first photo in Vanity Fair as an exclusive. So everybody was rushing to the TMZ website, and we were getting all these users. And we never know when they come. In fact, I can be speaking to you here, and Forbes or any other of these major publishers can go viral with some content, and we can be getting a lot of heat any time of the day, in any time zone. So to handle this, we decided to go for the public cloud. We wouldn't go for data centers or managing our own data centers. So we are operating in Amazon, in Azure, and HP Cloud. HP Cloud basically only for testing OpenStack, and I'll get into that. Azure, because we have this partnership now also with Microsoft, so we run active. A few clusters are in Azure, a few clusters are in Amazon. And we use this wonderful product, Nubium.io. It's a dynamic cloud manager. It was built by guys in our team. Now, that, again, another spin-off. Now it's a product in the market that you can use to do your cloud orchestration, to do automation, optimization, and it has support for AWS, OpenStack, VMware, vCloud, and also Azure. So Nubium is managing our clusters, and when we get these huge spikes from TMZ, he understands that, and he scales out and scales in when it's not necessary. And just for you to have a sneak peek at our AWS dashboard, you can see here that at some point when I took the snapshot, we were having in Web Spectator 315,000 concurrent users. So this is not sessions. It's at that moment there were 300,000 concurrent users, and they were publishing 42,000 messages per second, and the clients were subscribing at the rate of 1.8. Web Spectator is more in ingest than broadcast, because they have to ingest all these events coming from the browser. So when you scroll in Forbes, in a given interval, there are these events going to our platform, and from our platform to their Java servers. And we can have a look at that right now. It's no problem. Let's see what's going on. So I'll just use that in my own local host, which is cool. We use our own messaging server for our dashboard. So at the moment, as we speak, Web Spectator has 226K. So it's getting slower. And if we look into this, we just have a WebSocket connected to a server, one of our servers in Amazon. And all this data is coming from all the servers in the different data centers. And as you probably can see here, we also have a global cluster that's running in the two US coasts and Europe. And if you subscribe connected to the US and someone publishes in Europe, you'll get the message because it's routed globally through the data centers. And at the moment, the developers, so these 3 levels are the three SLAs. So we have developers, we have the corporate customers, and also the private shadow customers that have their own clusters operated by us, but those clusters are not multi-tenant, so to speak. Okay, carrying on. I won't lose my time here. So what have we learned in this now almost 4-year process? Obviously, when we started, we do what probably every developer does, is let's go look for some sort of solution, probably open source, that already does similarly what we are trying to do, and let's try to build this as a service. And guess what? In 2010, we were having Node.js. There was this cool thing going around called Socket.io, which, if I ask you who has used Socket.io, probably all of you have used, or at least you know about. And we started there. It was a cool project. It had these fallbacks, solved us a lot of problems. And the first lesson we learned is that Socket.io doesn't scale well. And strangely enough, this still holds true today. We had all sorts of problems. So the company was acquired by the ongoing group, the owner of Economic. So there was this manager guy that said, well, let's use this in Economic right away, while he was still in development. 100 users, 200, 300 concurrents, and around 1,000, everything would drop. But almost one user more could just collapse the entire thing. And it could depend. It could be the number 1,000, could be 1,001, but we were struggling hard to, when we looked more into it, because we started using it, just all the examples and, hacking, just doing things around and what it does. We didn't care what was going on in the background. So Socket.io had this Redis store concept. In fact, had this store concept that you can have multiple plugins. We were using the Redis one that would allow you to scale through multiple processes, node processes. Obviously, Node is single-threaded. We knew from the start that we couldn't run with only one thread. We would have to have several. We went to the using Redis store. Redis store basically in Socket.io syncs all the connection data between every node. So if you have two nodes, they are chatting through the Redis pub sub, sending information back and forth. If you have three, they communicate between them, all using Redis. And what is being synced? Handshake data with all request headers, query strings, and stuff. The IDs of all connections that are open, connected, and closed. Don't ask me why, but it's there. I think it's there still today. And also the room names and each ID that has joined the room. Room names for us was a great feature because we could use that for the channels that we were trying to implement with PubSub. So a channel would be just a room. And what we understood with that is the problem with Socket.io is as you add more nodes, you have more information going around. So if you have 10 nodes and the user connects in node number 10, there is a message going to Redis. There is this propagation of this event to all the other nodes, and the other nodes have to handle with this event coming from the other nodes, and also the events coming from their own connections. So we understood what was the problem. We were growing, and at some point, it's almost like, that little drop that makes the bucket just collapse was happening. And also, this is a great attack vector for Socket.io. If you just simulate handshakes with with a large amount of headers, the more you can, with very large query strings, all this has to be serialized to send to Redis and deserialized when it comes from Redis. So at some point you just choke the event loop of all the nodes and you have to restart the whole thing again. And by restarting, it's killing all the nodes. And so the result was obvious. Scaling by adding more nodes would be the solution, but in this case, just makes everything worse. So we ditched Socket.io. We found something because we needed some polyfill to do the fallbacks to the older browsers for XHR streaming and JSON polling for the IE6, and we went for Sock.js, which is a very lightweight implementation of WebSocket with fallbacks. It doesn't have rooms, it doesn't have all other niceties that we had to develop ourselves, which was great because we were also learning Node, and we had to develop more in Node. Remember, we started with Node 04. So now we are running in production with 010 and looking forward to 012 with all this stream stuff, which is great. So we learned that each node should be independent of all the other nodes. That's I don't know if this is obvious for you, but when you develop a node, you should keep your code in your architecture in a way that if you run several nodes just like that, if you spin more, each one would do their own thing without caring for all the others. In fact, they shouldn't even know that there are other nodes. So if I'm node number 1000, I'm doing my work, and I don't care if there is the other words are okay, if they are down, if they are dying, if they are, I don't care. It should be that way. And each node should only manage the state of its own connections. So I don't, if Renato or Pedro is connected to me, I don't need to, because I'm working with persistent connections in our use case, I don't need to tell the other nodes that Pedro is connected to me. We removed all this chatting between all the nodes. So no shared connection state whatsoever. And obviously we have these published messages that we have to share. If someone publishes in a node, we have to let other nodes know that there is this message so they can deliver the message to the connections that are subscribing to it. So we started using Redis PubSub because we were used to it, and we reached the limit of Redis PubSub 2, and we had to ditch that and go for a different thing. So we wrote our own router in C. In this case, we went for C with 0 and Q. So in this case, if you have a dropped connection, there's no problem. The client just reconnects and generates his own state on the other node. No problem. So it's the obligation of the client, and we have this in the SDKs, to resubscribe to all the channels that he was previously subscribing. And I can be connected to node 1, I fall, I drop my connection, I reconnect, and now I may be connected to node 4, and I resubscribe, so node 4 knows what I'm interested in, and it goes on. Also keep in mind that our service is at least once, at most once. We are working in at least once, but at the moment we are at most once. So what we guarantee is that each message is delivered to the subscribing at most one time, no duplication. But it can, in fact, be dropped. If the client is reconnecting, if it's subscribed too late. But there are many use cases like dashboards and other that can deal with this. So with this architecture, adding more nodes wouldn't affect negatively the existing ones. The other thing we learned is that for this load balancing, HA proxy is your best friend. Who knows what is HA proxy? Who works with the, okay, so HA proxy is almost the tool that everybody's using. So we can scale vertically by running several nodes behind this HA proxy. Normally one node process per CPU core that you have available. Generally a good practice. We started there, fundamentalists, but now we are more liberal. In production we can go sometimes to 30% more. And we control obviously the amount of connections that go into each server. Nubium is there to help us achieve that, and I will go into why we have more nodes than the number of cores. And also, if you have this HTTP mode in the HA proxy, and you have this balance URI depth, it's great for session stickiness. Because if I fall back a user for streaming, he is not a persistent connection, so he still has to, when he publishes a message, he will do a post. So if he publishes in 10 seconds later, he do another post. And I want that post to reach the exact same node where all the previous ones were, because that's where his state is. We don't share state between the nodes. So in fact, what balance URI does is, if you compose your WebSocket URL, your endpoint URL, in this case, my service /123 would be a hash that would be divided by all the nodes in your backend, and every request that has these two parameters, my service 123, would go to the same exact node that HA proxy selected to handle this. So it's very simple, and it's great for implementing stickiness. No cookies, nothing fancy, no IPs. The client can even change their IP and still work. HA proxy has a great stats page. Sometimes it really helps to. It's very easy. Just go there and you see what's happening at the moment. And it's wonderful for HTTPS termination, which is, as you can imagine, a problem. Can be a problem for Node with all the compute that's involved. And it's so much better than the cluster module, which we have tried. But the problem is the cluster module in Node relinquish the balancing between processes to the operating system. So it's up to the operating system to select which process is best. But the problem is the operating system tries to minimize context switching. And normally what it does, it wakes up the last one that blocked. And as a result, you have one or two processes that are running really hot and the other not so much. So if you have a 16-core machine, you have two nodes, really almost 100%, and the others 10% or less, which is a problem. In Node 12, they changed this, and now it's round robin, which we would lose the stickiness with that. So it wouldn't be a solution for us, but at least for REST APIs, cluster is becoming usable. Cool. Lesson number 4. Clients should request a server to connect. You might say, why don't they just connect to some proxy and transparently you route the traffic? The problem is that you have a scaling problem there in this proxy. We have proxies of balancers, and it's a nightmare. So what we decided to do, and this works for our use case or for any REST API, we just scale horizontally by running several HA proxies with nodes behind it. So we call it the scaling unit, and you can customize it. You can have a scaling unit of 8 nodes, of 16 nodes, of 100 nodes, depending on the number of cores that you have available in each box. And it's up to these scaling units, it's up to the application to register itself into this load balancing service directory, saying, okay, I'm here, I'm a 16 node scaling unit, and I'm ready to do service X for SLA Y. Okay? So it's up to this service to compute the best server for each SLA. It's very, very simple. You don't have to go into fancy algorithms. We have a few metrics. And the good part is the client, when the client needs to connect, he goes to the service, he requests the server. The service gives him the best server for its SLA, and you just connect to it. So it's, you have this extra round trip, but we are talking about persistent connections. If you are in the stock update example, if you're there for 30 minutes, you have this little round trip of 100 milliseconds to get the server, and then you connect, you have a WebSocket for 30 minutes. So it's 100 milliseconds in 30 minutes. It's absolutely feasible. And what happens if you have a dropped connection, because we don't have shared state, no problem. You just go into the service and you request a new server and you start again and you regenerate your state, and this goes well. And this is very easy to scale, this service, because it's so little, it's not time consuming, not compute consuming. We have these workers in background calculating which are the best servers and updating these hash tables, and what this, when you make a call, you just say it's this server that you must connect. So it's very fast. And also a good part is this allows you to swiftly divert traffic based on anything on your application, not just IPs. So you can, if Renato is a developer, he upgraded his application key, we can move him to a different cluster with a better SLA just by instructing this service that all the connections for his API key should go to other cluster, to other server. So it's easy. I don't know if you use a lot AWS. This leads to, I'm starting to rush because I'm getting out of time. So if you are using AWS, this is somehow not expected, but you should prefer larger instances. When I mean larger instances with more cores available. So this mainly because these larger instances have better network performance. So Amazon has these templates, and as the number of cores is growing, also the memory of the server, of the instance, and also the network capability. We are a real-time messaging service, so network is important for us. And one thing that is quite strange is the price per core is always the same. So you pay per hour 0.05 per core, whether you are running a 2-core machine or a 32-core machine. And if you are running a 32-core, you get 60 gigas of memory, which means you can run 32-core, you can run 40-ish nodes, and they could all go to 1 giga memory, and you still have 20 extra. Which this in fact means that you can run more nodes in each instance. It's great news for the notorious Node.js memory limitations. The only drawback is you need a little bit of scale to make this work. Otherwise, you're paying for a very large box that's idling there with a lot of cores, and it's not effective from the cost point of view. But for our scale, it's great. Number 6, and it's 7. It's this and another one, and I'm finished. Have you heard about immutable deployments? Probably it's everybody now talks about immutable deployments, and it's in fact we are using them since the early beginnings. An immutable deployment is, in a very simple term, you provision a new server or cluster, whatever. You configure it, you test it, it's good for work. You put it in production, and you don't touch it anymore. You don't update it. You don't go there and change config. You don't go there and patch a new version. It's there. It's something that you know it's working. You need to upgrade, no problem. Just build a new one with a new version of the software on the side, and you turn your load balancer to that new one, to the new server, and you ditch the previous one. If you want to be really careful, you can keep the other one running for 1 day or 2, and if something really cracks up, sometimes it's after a few hours that things crack up, you can just revert to your previous version. So you always know what is running inside each box. Also, I would advise you for deployment speed to use pre-baked images. So you just compute your image, you install the software, and you just leave the configuration for the deployment. This means is when you provision the new server, all the software is there. You don't have to install it. You just have to configure it to do what you want it to do much faster. We can spin up 32-core boxes in Amazon in less than 3 minutes with Ubuntu. It's running. Which means, obviously, we needed auto-scaling. And my advice to you, if you are scaling out, measure what's important for your users. Whether it's connection elapsed time or request latency, you can measure this in several points of the globe if you want. Not just CPU. CPU can be sometimes very deceitful. You can observe different things only looking by CPU. And also, obviously, consider using an automation tool. And by the way, Nubium.io is great, so check it out. Last but not the least, always benchmark with production loads. So I think this is obvious for you. For us, at some point, we were trusting in our lab stress tests, but sometimes something that worked with 50K concurrents in the labs would struggle with 20K real users. So lab stress tests are great to have a ballpark view of estimate of your limits, but real world is a different neighborhood. You have slow readers and sometimes problems with back pressure, with fast writers. You have misbehaving clients that are not respecting the protocol. You have unstable networks, lots of connections, namely in mobile. In mobile devices, it's normal for the connection to drop, so you have to go again through the cycle of establishing a connection which is heavier. And what we do is normally we deploy our new version with the current version. We mix. And so it's sort of an A/B test. So we know we have version n+1 running alongside with version n. And we measure the new version metrics. We gather the data and we compare to the data that we have collected when we measured the previous version, when we launched it, and we compare. And we decide if this version is going great or not. If it's going great, we just deploy across the board. If not, we can revert easily, and Renato has some more work to do. Also profiling. We used all the tools, profiling the V8 can get really messy. It's quite difficult. There is this great tool, Node.js. They didn't pay me for the advertisement, but they are great. You can run it in a selected node to get great insights. It's free because you are only using an agent. You can have several accounts with one agent for if you have to run more. It's possible. Developers do this with us. We have developers with 5 free tier account. When they kept the messages, they change the API key and start using the other one. So it's cool. We know they are doing that. And NodeTime.com helped us a lot to spot memory leaks and optimization opportunities, and we can just turn it on and off when we need. So if we are in a spike and we want to know what's going on, we turn it on. The good part is, since all the nodes are doing the same, inspecting one gives you a pretty good image of what all the others are doing. So you're okay with that. So in the end, it's in God we trust. All others must bring data, so we have to make decisions based on data. And this may sound easy. It's not, but there are a lot of techniques and a lot of great blog posts out there explaining what I've just said in much more detail. I just wanted to share some pointers with you. And I thank you. So what I get for you. Try real-time framework.realtime.co. It's free. And you have my contacts there if you need anything. And if you have any questions. So Skype is a great tool. We tend to. Yeah. Our expensive HTML.
I think we can speak Portuguese now, right?
Podias-me ter dito mais cedo.
Questões?
Não ter máquinas físicas?
Sim. Não compensa para vocês falam.
Se olhássemos só para o custo da operação do data center, se tivéssemos da aquisição das máquinas, provavelmente compensaria. Seria mais barato. Só que a vantagem que existe com a Amazon é que temos largura de banda, não temos restrições de largura de banda. Nós não conseguimos esgotar a largura de banda da Amazon. Gostaríamos, mas não. Netflix está lá para isso. Não somos nós. As máquinas são sempre atualizadas. Não temos que nos preocupar com... Compramos as máquinas e 3 anos depois elas estão completamente obsoletas. Portanto, estamos sempre a usar... O nosso receio inicial era se máquinas virtuais iam aguentar este tipo de carga. Se iam fazer o que... Mas a verdade é que aguentam. Máquinas físicas, nós temos clientes que têm instalações on-premises, a correr em ferro. E é mais rápido. Conseguimos ligar mais gente, conseguimos fazer mais mensagens, mas de vez em quando o ferro tem problemas e enquanto nós na Amazon mudamos a instância, aliás nem somos nós, o Nubia me trata disso, não é? percebe que as métricas daquela não está bem, retira do cluster, lança outra igual e avisa o pessoal do DevOps para ir olhar para ela para ver o que é que está lá a acontecer. E se eles não olharem ao fim de uma hora, aquilo é desligado porque está a gastar dinheiro. Com máquinas físicas não é bem assim, não é? Já para não falar da questão da escala, que é, chegando a um ponto em que chegas ao limite das máquinas que tens, se de repente entra o Web Spectator, traz um cliente novo que agora fez uma parceria com o Facebook, e nós morremos na praia porque no momento em que tínhamos que escalar não temos. Tínhamos que comprar máquinas HP ou ADL, podia não haver, não é? Por isso preferimos pagar mais, a verdade é que se o custo é maior, mas depois também com a Amazon, não sei se conheces o modelo de pricing deles, podes reservar máquinas que tens 40, 50, 60% de desconto. Portanto, se tiveres uma boa noção do que é que vai ser, do que é que esperas ter no próximo ano ou 2 anos, podes antecipar e conseguir reduções de preço. E aí, em alguns casos, até pode sair até mais barato do que teres o hardware.
O que vocês usam à frente do HProxy? Quando alguém chega ao domínio realtime.com, fazem com o caso para saber que servidor é que vai, mas vocês não têm...
À frente da HProxy?
Yeah.
Ao cliente.
Ok. Para isso é que serve aquele primeiro round trip, então?
Isso.
Ok.
E nós fazemos, basicamente, nos dizem, mas espera, então, mas como é que esse serviço também tem que escalar, não é? Só que esse serviço escala muito facilmente porque é um serviço REST muito simples e vou-vos dizer aqui uma... Podia ser a lição número 8, que é balancear por DNS não é tão mau quanto parece. Se tiveres um DNS a apontar para várias...
Se o serviço falha,
Vai, mas por isso temos em várias zonas de disponibilidade. Temos uns na Europa, temos outros na costa oeste americana, outros na costa este. Não, sim, mas falharem todos já aconteceu. Atenção. Lembro-me em julho, há 2 anos atrás, a Virgínia. Diploma mal feito. Aconteceu uma vez. Mas felizmente também não fazemos para todas as regiões ao mesmo tempo. No fundo, pode acontecer, mas... Aliás, vocês repararam quando eu vos mostrei aquela imagem do dashboard, havia aquele cluster que é um cluster lógico que está em 3 regiões do mundo diferentes, não é? A Amazon tem um serviço bestial que é o Route 53 que permite fazer balanceamento com base na georreferenciação. E o que acontece é se de repente a Europa tiver com um problema, nós podemos basicamente chegar lá e dizer agora o tráfego que ia para a Europa já não vai para a Europa, vai para o que estiver mais próximo, dos Estados Unidos ou outro sítio qualquer. E, portanto, é muito fácil.
Aquela tensão também não é provavelmente um problema para vocês, não é?
Por acaso é. Não sei se uma das coisas que... já agora... Não, é talvez a coisa mais importante. Por exemplo, o Web Spectator, nós temos um SLA muito apertado. Eles medem. E quando falhamos, temos que nos indemnizar. E basicamente nós medimos a latência. E basicamente isto é a latência média das últimas... Isto vai atualiza de 55 segundos. E para nós é extremamente importante. E obviamente podes reparar que há aqui uma diferença entre este cluster e este. São diferentes. É normal esperar end-to-end em qualquer sítio onde te ligues no mundo tenha uma internet decente, teres um round trip de 150 milissegundos. Aqui na Europa chegamos a ter 20 e 30 milissegundos. Nos Estados Unidos, dependendo das cidades, podes ter até 5, 6 milissegundos com a internet. Okay? O nome? Em Moçambique? Pois. Ok, 300, 400. Aí é outra conversa.
Vocês têm IPs virtuais à frente de cada uma das vossas máquinas e quando reformam uma máquina apontam o IP virtual para outra?
Isso. Basicamente é isso. Que é bestial porque permite dar-te uma versatilidade muito grande nas tuas operações, porque no limite até podes fazer nós agora já não o fazemos, mas houve uma altura em que fazíamos um rolling deploy, que basicamente lançávamos uma máquina ao lado que ficava com o IP que era da outra, da que estava em produção. Como o IP não está na máquina, está na rede, neste caso da Amazon, e no Azure é igual, naquele momento da mudança havia uma latênciazinha um bocadinho maior, enquanto internamente eles roteavam o tráfego para a outra, mas no fundo tu desligaste um servidor e ligaste outro e não tiveste downtime, e as ligações nem caíram. Não é? Nem sempre, às vezes... Normalmente fazemos isso. Quando fazemos, portanto, o Nulium faz o scale-out quando atingimos os certos patamares que estão definidos. E depois, para fazer o scale-in, primeiro retiramos do balancer. Ele deixa de aceitar novas ligações. Esperamos um determinado tempo para fazer o drain das que estão lá. temos sorte porque a maior parte dos utilizadores estão na web e, portanto, andam a fazer page view e ligam-se muito rapidamente. As ligações, algumas são de curta duração. Portanto, eles estão ali a seguir, já se ligam noutro sítio. Só ao fim de algum tempo eles não se desligarem. Há um comando que é enviado para os clientes que lá estão ligados, a pedir-lhes graciosamente que se desliguem e que se liguem noutro sítio qualquer. Para podermos desligar.
Uma conexão pode mandar ao cliente liga-te a outro.
O servidor pode pedir ao cliente para... Não diz para se ligar ao outro, diz, olha, desliga-te.
Ok.
E ele, por sua vez, vai round trip, vai buscar outro servidor, liga-se.
Ok.
Desde que tenhas pelo menos um a funcionar, a coisa vai andar.
Essa haste do distribuído. Posso fazer uma pergunta? Desculpa. Essa haste do distribuído dos servidores. Vocês têm a replicar geográfica, não é? Têm vários data centers. O que é que usam para fazer a replicação? Vocês calculam centralmente e depois replicam?
Ou seja, todos os servidores enviam as suas métricas, número de mensagens in, publish, subscribe, etc. E enviam para um cluster Redis, PubSub, onde esses nós que servem esse serviço de balanceamento estão a subscrever. E como aí controlamos, aí estamos muito longe de atingir o limite do...
E depois os clientes quando estão numa determinada zona vão-se preferencialmente ligar àquela zona. Portanto, é tudo naquela zona, não é?
Sim. E depois temos os tais rutas que ligam regiões que estão obviamente otimizadas. Essa foi talvez a parte que nos deu mais trabalho de fazer, que é, por exemplo, o PubSub do Redis, agora do cluster. Quando vocês publicam uma mensagem, essa mensagem vai para todos os nós, independentemente se está lá alguém a subscrever esse canal ou não. E isto gera mais ou menos aquele problema que o Socket.io tinha, né? De repente há congestão na rede. O que nós tivemos que fazer foi uma coisa mais evoluída, que é, na presença de uma mensagem, um router só a envia para o outro router que ele conhece, se souber que há interesse nisso. Até uma patentezita que registámos, que explica esse processo. Com árvores, binárias, etc. Para basicamente não fazer com que cada mensagem que sai de uma região para a outra só saia se for produtiva, se lá na outra ponta tiver alguém interessado nela. Né? Até porque também se paga tráfego entre as diferentes.
Não pode acontecer que não receba a mensagem?
Bem, pode acontecer porque o TCP falha, não é? Porque há ligações de... Mas em termos aplicacionais, não. Por isso é que a nossa garantia de serviço é at most once. Sim, claro. Quando há o primeiro que subscreve, avisa os outros routers, olha, eu estou interessado neste canal. Portanto, se tiverem alguma coisa aí relativa a este canal, mandem...
Pode acontecer que antes que a mensagem chegar já existe alguma coisa para ele. Ou seja, o sistema não é consistente, de qualquer forma.
Não, de todo. Isto é claramente... É tolerante a partições e é available. Tem AP. Portanto, o teorema de capas, consistência... Não. Estamos agora a olhar para a possibilidade de ter o at least once. Mas tem os seus desafios. Como é. Não somos um sistema de queuing. Message queuing. Não somos precisos de queuing. Para isso temos um outro serviço, já agora, que é o Real-Time Storage, que utilizamos o DynamoDB para fazer a persistência e depois utilizamos o Real-Time Messaging para fazer a sincronização. E aí já tens um nível de serviço que já podes garantir, para fazer um chat, o tipo que se desligou, houve mensagens que outros enviaram, quando ele se religa vai fazer o pull das mensagens e depois a seguir, portanto faz pull para receber um estado e depois a seguir sincroniza com base nas atualizações. Okay. Todos os SDKs estão open source e começámos há relativamente pouco tempo com, aliás, o Xamarin que publicámos hoje já é third party, portanto, feito por um developer externo, com o nosso apoio e fora, mas já não seremos nós a manter diretamente. Os outros temos cerca de 20 SDKs, PHP, Ruby, Python, C. E esses somos nós que mantemos. Alguns componentes, podia ser interessante, temos uma coisa que é a nossa biblioteca de componentes, algumas coisas lá que eventualmente podemos vir a abrir. Mas a política da companhia tem vindo a alargar o âmbito do open source.
E fazem algumas customizações de open source ou usam só exatamente o que está
Bem, o que que nós usamos de SOC.js tem pouco a ver já com a... Tirámos as partes que nos interessavam, tirámos outras, há uns quantos transportes que estavam lá, acho que um bocadinho for the sake of it, mas para nós não, frames e coisas assim, não nos interessavam muito. Mas de facto isso tem acontecido. E o preço é $1 por milhão de mensagens, pá, é barato. E está integrado com as gateways de pagamentos, com as gateways de mensagens do APNS, GCM, pá, isto é mesmo bom. Check it out. Ok? Obrigado.